Hi all, hope you're fine. And myself, Dr. Sharat Kumar, Professor Ed, Department of Information Science Engineering, MIT, Mysore. So, as previous sections have been discussed with what is DBMS. So, what is DBMS? So, first initially what you tell, it's a what is DBMS, right? So before going to chapter 2, what I want to talk about entity relationship diagram. So I'm talking about what is DBMS, which is done in previous sections, right? So data, so DBMS, so DBMS, so database, what we call as, right? So database, it's a collection of related data items. Collection of related data items is called database. So management is called as, which is manage the database. When you turn a collection of database, for example, if I consider employee database, so employee database as company. So employee database as a with the company. Company belongs to employees. So employees with the employees entity, right? So department as a entity, project as a entity. So here the employee defines with SSN, department defines with department number, project defines with project number. Entire you want to manage by insertion of employees. Maybe for example, consider MIT as a database. Here we have a employees, here we have a courses, and the employee IDs, courses as courses IDs, right? Like that there is a management. There is a management, like employee maybe quit the departments, or employee maybe change the department, or employee maybe quit the college itself. So you want to maintain the employee details by managing a database like insertion, deletion, updation. So now some purposes may be shifted to assistant to associate to purposes, right? So that time you require to manage a database. That is called management. That is called management. So database is a collection of related data items which is talks with management, that is done through what is called insertion, deletion, updation. Deletion, insertion, updation, which is a DBMS can be speaks with languages, right? Speaks with languages like DDL, DML, right? DDL and a DML, where DDL, data definition language, speaks about creation of a table, alteration of a table, right? And DML speaks about insertion to tuple, deletion to the tuple, updation to the tuple, right? That is what we done with the previous section of DBMS with a database, with the management like insertion, deletion, updation, providing a security that is which is speaks with the DBMS language. Like what we speak various languages like our mother tongue called Kannada language. Then we speak about through English language, right? Like that DBMS as a language that is one with DDL, data definition language, and data manipulation language. So this is the content what we discuss in previous sections. So now I'll go with the chapter 2 based on this. I'll go with the chapter 2, that is an ER diagram, entity relationship diagram, entity relationship diagram. So we speaks about entity relationship diagram. Okay, entity relationship diagram. So entity relationship diagram, I'm telling 3 times because it must be, because DBMS as diagrammatic. So when you talk about database with the tables, so table as powerful as diagrams. Table as powerful as like diagrams itself. That's what, when you want to represent a DBMS, a database management through diagrammatic, you required entity relationship diagram. Okay, so for example, I have seen a lot of as previous section. Consider if I tell that company as a database, then employee as an entity, what we call as employee as an entity. So employee can be tell like this, employee as a entity, right? I told employee as a table. So when you go for the creation of a tables, talks about DDL or a DML, what it talks about, we can tell that employee as a entity, employee as a table, right? Like that, entity it as employee. Entity is a employee for, and company database and a company database. Okay, so company employee, so company has employee, company has departments, company has departments. So company has departments, company has departments, right? So employee can be represented through SSN. Company has employees represented through SSN as a unique key. Department goes with D number. Department goes with D number. So underline, I will tell more details about in the thick section of entity relationship. In the more sections, I will discuss how this goes with things as, right? So entity tables. So entity with the tables, entity with the tables. So now I want to talk with a relationship. Now I want to talk with a relationship. So employee works for department. Employee works for department. Employee works for department. So it is entity. This is what is called diamond symbol, has been called as relationship. So with the other entity. So entity as a relationship with the other entity through the relationship is called a ER diagram, which is called as database can be represented through diagrammatic way is called entity relationship diagram. Entity relationship diagram. So employee works for department. So somewhere employee can be manage department. Employee can manage department. So employee can manage department. Employee can be manage and department. Okay. So this is what we call as entity relationship diagram. Entity relationship diagram. So employee works for department. A relationship can be built. Employee manage department. So as HOD of the department can manage the department. So as employee works for department. Okay. So this is what the diagrammatic way of giving a DBMS is called entity relationship diagram. Okay, entity relationship diagram. So with this, I want to go with data models. So when you want to explain the entire design of ER diagram, so what I want to do? So how to go this diagram directly, right? So I cannot tell you I want to go with a company. So what is the requirement of particular company? What the company, for example, like a client appears to the company. So you maybe want to get a software. So what he does? Directly you cannot go to relationship, right? Directly you cannot write entity relationship diagram. So you want to think about requirements. Then I want, based on requirements, I want to build ER diagram, right? So that's the possibility I want to requirement I want to consider. So that's what I want to go with ER diagram with data models. So ER diagram with data models make the real system, requirement, then analysis, then build a beautiful application. So DBMS is such a way that it's a very needed subject, very needed application, needed a software for entire so many applications. So if I go for any of the shop, for example, if you go to the big market or a big basket, we call as, or a big bazaar or a Reliance Fresh, anything, any shops we visit, just a database, right? Because every system has been stored. Just people will come back to the particular purchase the item, they purchase entire items, they go for billing, they will see this the item that you want to purchase, just scan it, just compare with the system already stored, just compare and display the item rate, right? This is done with the database. So everywhere, wherever you go, wherever your mind itself, your whatever I am talking myself. So I have a database of entire things. I have a database of entire storage of huge number of things in my mind, right? So like that, that's the beauty of this DBMS. That is the beauty of DBMS. Okay, it's one of the fantastic subject in the information science engineering and computer science engineering. Okay, so data models. So what is data model? Because so already maybe some previous section we discussed data models. What is can be data models can be done. So because we have three models of data models. So in this I'll tell a little go introduction. How can we build a ER diagram through data models? Okay. So data models, it's a collection of. I'm telling that it's a collection of concepts that defines the structure of database. Structure of database. So I'm telling that it's a collection of concepts that define the structure of database. Define the structure of database. So I want to collect the concepts which can define a structure of a database. The concepts can be your languages, right? So DDL, what you call a data definition language, it defines a create table, right? It's defined creation of a table. It defines alteration of a table. It defines with a DML called insertion of a tuple, deletion of a tuple, right? Updation of the tuple. So it collection of that concepts which can define the structure of a database. It's define a structure of database. The structure can be defined as, because when you tell structure, you must define as. So define as relationship between the tables, right? Between the tables. When you build a beautiful database, like bank database, so bank has branches. If I consider the SBI as a bank, SBI has branches, right, in entire Mysore. So if I consider SBI is in Saraswatipuram, SBI is in Koyapanagar, SBI is in TK Layout, right? So n number of branches. So bank has a branches, each branch has employees, right? So branches has employees. So employees work for branches. Branches provides loans. Branches have customer. Employees has to maintain the customers, right? Like this, that's the beauty of relationship defines between entities in a database. So that is called, what is called relationship I like to speak about. Okay. So then it's defined the constraints. The constraints the table can have. So constraints that provides in a particular entity or a table. Okay. So constraints means the primary key, foreign key, what we'd like to talk about. The primary key, it's uniquely identify table, that is called primary key, which uniquely identify the table in a database. Okay. For example, what I told employee as SSN, department as department number, that is called a primary key because it's uniquely defined the entire table. Like that, foreign key means which refer the primary key of other table. Like employee as the department number, so myself working in information science engineering department, so my department number is 4. It refers to the table of a department table. So when I tell an employee with a department number, so this department number refers department number. That is called foreign key. So you want to follow this all the key constants where primary key cannot be null, because when I join the particular institution, I required to be maintain a unique key. That is called my SSN, right? My SSN. That is primary key. Okay. So when it talks about foreign key, I am working in the department number 4. We have in entire MIT, we have 5 departments, right? So any of the employee join the entire college, they must work in a particular department. They cannot tell that I am working in the department number 7. There's no department number 7 exists. We have only 5 departments, right? So that's the rule you want to follow while defining the structure of database. That's the beauty of the database, what you call as, right? Then we have data types. So we have n numbers. As you've seen, data types have been seen data structure. When you have when I talk about the information science or a computer science, I want to think about a lot of things, right? The basic core. When I joined 3rd semester of my information science or a computer science department, first my subject is data structure. The beauty of data structure makes database perfect way. Makes the database with a perfect way. Such a way that built had. Such a way the structure goes. Okay. When I talk about data structure we define data types. The structure of database has been defined with fantastic memory storage, fantastic how the data have been designed. Right? Like that, in the true data structure, we comes with database where we contain data types which define the variables. Right? Like that, we have a database data types in what you call as DBMS. Okay? So this is what the data model talks about. Data model talks about. It's a collection of concepts that define the structure of database. With structure can define with relationship, constants and data types. Okay, so relationship and constants and data types. So if I tell that if I want to write a table, small table, I will write it out because it makes easy to analyze what data model is all about. So create table. So create table employee. So I'm making to create a table called employee. Table called an employee. Okay. So employee as SSN. Employee as SSN. Employee as SSN, which defines through varchar. Which defined through varying character. So it speaks about the varying character for SSN. SSN is a social security number which may contain mix of characters and numbers. Mix of characters and numbers. So if I tell USN, you people have 4MH IS 18101. So it defines 4 is a region code, M is a college code, and 18 is a year, what the year you people are joining to engineering. So then it is defined department. Then we have a roll number, that is 101. It's a mix of length of 10. It's a mix of integer and a character. It's a mix of integer and a character that is defined through data type called varying character. Varying character, that is varchar. That is an varchar. So I will define with 20. So length can be up to 20. Maybe it varies, depends upon domain, depends upon the application requirement. I'm going to fix the length to 20. Fix the length with to 20. Okay. So this is, so see what I done. So I done with, so SSN define varchar. Okay. Then I'll talk about age. So age is integer. Age is integer. I'll define with a 4. I'll define with the age as an integer with the 4 as a length. I may be 4 or maybe 2, that requirement. Okay. I will define other one with department number. So which department the particular employee belongs to, right? So department number integer defines integer. So department number defines integer. References. So references department's D number. References department D number. So references department D number. So thing is, so I'm creating a table called employee. Creating a table called an employee. So SSN defines the primary key. Defines the primary key. What do you call as PK? What do you call as PK? So department number integer references department number, that is foreign key, FK. What is called? Foreign key. That is called foreign key. So constants talks about rules. Constants talks about the rules, right? It talks about the rules, what I told through this one. So SSN is a primary key which is defined in the table, right? Which is defined in the table. Then I'm talking about references. So integer, what is department number the employee belong to, references other table called department, that is department D number I am referring, right? That is called foreign key. So we maintaining constants. So there is data types that defines. So I'm defining SSN with a varying character, age with a integer, maybe name with character. Right? Maybe name with character. So I define name with a character, and date with a date, time with a time. Time as a data type. Date we want to define date as a data type, right? So that is called data types. So DBMS supports varying character, float, integer, number, date and time. So this is data model that defined with a data structure. So structure of a DBMS can be defined with data types, right? Data types. Then I have a rule called foreign key and a primary key, where primary key cannot be null. Primary key, that what the SSN defines must not be null. and you want to refer the existing departments for D number, Then we have relationship. I told relationship as employee works, so myself employee working for ISE department, so employee has to work with a department number, employee has to work with a department D number. So this is talks about relationship, So this is the overall the picture of data model, data model. So now I want to talk about data model. This data model I discussed with the entire structure I define with the requirement to be concerned for how to learn data models, right? So this can be applied for database design. Where we think about the database design can be done with so data structures and software engineering. The beauty of software engineering can be included for designing what I call as database. So data models for database design. So database model for database design. So while designing database, you want to consider following things. You want to be involved in software engineering requirements, things has to be included before going to a DBMS. Okay. So as you learn in software engineering, there may be waterfall model. What do people are learning, right? In waterfall model, what do we do first? So first we do requirement collection, right? So you go analysis, we discuss with the clients. For example, if client name appear, I want to get the software to be done. I require the software. For example, as a college, I may require a software called ERP. So I told, for example, myself, customer, I come to visit to your college and request for ERP. So I'm required to develop ERP. Can you help me? So first thing you want to discuss with the client. So what is your requirement? How to want to look it out? How it must be? So what are the things that you want to consider for development of a wonderful software, right? Through using DBMS. So data models for database design, that includes the first thing is you want to go with mini world. So okay, I want to go with mini world. Okay, so I'm going to mini world, means it is considered entire world because the software has no criteria, so it is covers entire things, is entire world. This what it comes with a mini world. Okay, mini world. So then I'll go with requirement collection. Requirement collection. I'll go with a requirement collection. So first thing I want to analyze is, as I told, any customer appears, the first thing you want to consider a requirement. What is your requirement to develop a software? As a software engineer, the first step is to discuss with the client, get a requirements. As you studied in software engineering, because software engineering course is a base course for any of our engineering. Like information science or computer science, as a software engineer, tomorrow you felt software engineer, you require to know the beauty of the software engineering course. It's one of the fantastic course where it starts with the requirements, then analysis, then budget analysis, right? What it does, right? You design, you then go for first requirement, then design a fantastic diagrams with a class diagram, UML diagrams, then we analyze with the solution, prototype, want to build it out. Then we come with giving a budget, how much budget requirement, and designing entire beautiful models, right? That we does in what is called software engineering. The beauty of that fantastic thing that we studied in maybe in third or fourth semester people have studied, right? So like that we have a requirement collection. Requirement collection has following requirements. One is data requirements. So other one is the functional requirements. So two things as you want to spark. One is a requirement collection through what you call as data requirements, that is belong to database, So functional requirements belongs to class diagrams, the flow of the entire the process with the operation specified, with the UML diagrams, sequence diagrams, what we call as. So that is comes with the functional requirements. That is comes with the and functional requirements, right? So that's what the mini world requirements. We're going with data requirements, which talks about what is the database design, how it look like. So how about the entire view of system, how we store the data in a things is, right? Other part of things is comes with the functional requirements, which speaks about class diagrams, UML, operation that specifies. Operation that specifies. Okay. So data requirements as following things is. If we want to go into data requirements, if I speak, there is conceptual design. That speaks about conceptual design. That speaks about logic design. It speaks about logic design. And that speaks about physical design. That speaks about the physical design. It speaks about physical design. When it talks about data requirements, then I comes with a conceptual design and logical design and physical design. So conceptual design speaks about how data can be viewed. How data can be viewed. That is through entity. That is done through an entity. Logical design speaks about conversion of this view to a storage purpose. Due to the storage purpose. Okay, due to the storage purpose. So if I tell that how the conversion can be done, so I will tell one small example, I will give it out. So it's easy to understand and easy to analyze. Okay, easy to analyze. So as I tell you, I will take the same example. Okay, what I done for employee. So as employee, as SSN as a key I told. Okay, employee as a SSN with a name as a attribute. So then I speaks about department. Then I speaks about where D number and D name D number and a D name, where employee works for department. So this is the view that goes with conceptual design. It's a view that goes with conceptual design, how user view the data. Entire view of the database, that is through viewing a database. That is done through conceptual design, where it speaks about entities, it speaks about relationship, it speaks about operations that can be done for a database. That is conceptual design I am doing here. Okay. Then I want to speak about logical design. A logical design. Say this. So this is the things is. So then I will go with a table. Employee as a table with SSN name. Then I'll go with department number. So employee works for department. I'm building a relationship there. So taking a diagram, convert to table. And table. Then I go with department. So D number, D name. D number and a D name. So employee SSN name, because it's a relationship between employee works for department number. So myself working for information science engineering. So and SSN name and which department I am working for. That is table I am built it from diagram. Right. This is a conceptual design. This is a logical design. That is a logical design. So employees SSN name and a D number. Then I have another table called department. Department has D number and a D name. So department number 1, department number 2, department number 3, department number 4. Department 1 can be what you call as civil, department 2 as CS, department 3 as EC, department 4 as IS, department 5 as mechanical, right? So this is department, this is the departments, this is the employees. This is called logical design, which is called as a relation model. This is called as a relation model, right? So because this relation model that we have built it, we have various models, right? We have a hierarchical model, we have a network model, we have a relation model, we have object oriented, where it speaks about what the relationship speaks about tables. We say about tables, right? It defines with a varchar integer, small number of data types. When it talks about object oriented, what you call as Java or C++ with the OOC, what we call as, it can be added with a database for describing huge number of entities attributes. Huge number of entities attributes can be defined through object oriented, which overcomes the relation model drawbacks. Relation model drawbacks. That is done through what I call as relation model to overcome with the OOC. That we done to define with the various model that DBMS and DBMS supports. So here the concept design, the diagrammatic logical design defines the tables. Then I want to talk about physical design, which talks about storage. You want to store this data, right? So you will enter. So myself, we have 250 employees in MIT. We enter the entire table information for employee table, right? So what do you want? Go on adding. So for example, myself, I will add the data called 11. So data 11, name SS, department number 2. So like this, I will store 250 tuples. 250 tuples have been storage. So data becomes gone. It must be stored in database, right? It must be stored in database. That is done through physical design. That is done through physical design. While designing, I will think about indexing. I'll think about indexing. So wherever you go, for example, if I go to the office and tell that what is the fees I want to pay for a particular student, I will tell. So for example, myself, Sharat. So I'll go to their office. So myself, Sharat, what is the amount I want to pay? I'll ask for exam check, what is called account section. What they will tell? Who are you? Why you came here? Who is Sharat? Like this they will ask, right? So question is, it's too difficult. So instead of telling my name is Sharat, because Sharat may be in IS or CS or EC or a mechanical. In mechanical we have various semesters. We have in IS we have various semesters. We may find 20 people of Sharat Kumars in MIT, right? So it's very difficult for people to go for what you call as by name itself. That's what you required, USN. USN as primary key. It's a primary key, what you call as, right? It's a primary key that defines. So you want to tell physical design while going for storage, you want to tell that SSN is a primary key which define the table employee. Which define table employee. SSN is a 1-1 that defines table employee. This SSN is a 1-1 which is unique key that defines the employee table. Like that, a department has 5 departments. We have 1, 2, 3, 4, 5 is a primary key that defines, right? So while designing, going for physical design, it talks about storage, it talks about indexing. Indexing is a fastest retrieval of a particular tuple that required based on the primary key. Based on the primary key. It's much fastest retrieval because no people will wait for half an hour for getting retrieval, right? So they wait more 50 to 60 seconds. It's just too hard to wait. Like that, you want to think about physical design. So this is storage part that speaks about while going for what you call as data requirements. While going for data requirements. So then if I go for functional requirements. So functional requirements speaks about a functional design. A functional design. It speaks about the one when I go for functional requirements, it speaks about functional design, like your software engineering speaks about class diagram, UML diagrams and sequence diagram with operation that is done through what is called functional design. That is done through and functional design. Functional design. So this what we speaks about this. So this is goes with like that. Then I will go for using all this operation. I will go with application development. I'll 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 go with application development because I have requirements. I have done all the sequence diagram, I have done a functional requirements with the sequence, human diagrams. Here I have done with conceptual design, logical design, what I call as physical design, everything is done it, right? So now I am going to design application using front-end tools like Java, PHP, Python, .NET, right? So everything I am utilizing to develop an application development, right? So using this application, next what to do? Application afterwards, you want to go for implementation with what we done through application. Then I will go for transactions. Then I will go for transactions. Then I will go with transactions. Then I will go with transactions. Then I will go with transactions. This function requirements can go with physical design. It's go with and physical design. And go with physical design. So this is the way that comes from. This is the way that have been done. Okay. So function design goes with the physical design. From physical design, I am going to implement transactions. Because one transaction, two transactions. If I go for requirements of railway, so if I go for requirements of railway, then I want to think about transaction. So there may be booking, there may be deletion, there may be updation, there may be scheduling, right? Huge number of trains, huge number of traveling the peoples, huge number of customers, right? So you want to manage entire things. You want to manage, so see the challenges in what I call as a dynamic database, what I call as a railways, dynamic database, because Lord, a huge population India is, huge population of booking, huge population of rescheduling, huge population of cancellation, huge population of waiting for a particular train, right? So you want to manage a train, you want to manage the employees, you want to manage customers, you want to manage the entire booking system, right? That is done through what I call as database. That's what application have been developed using various front-end tools like your Python or a Java or a .NET, what we call about. This comes with going for transaction based on the functional requirements. So functional requirements can be like this. So if I talk about like this, so if I talk about data independence, it appears. So this is data independence because it not depend on any of the things. As this is data, so data independence. So data independence, that speaks about this part, what the logical design, physical design, application development with the transaction defines data dependency. So define data dependency. So it comes with many world requirement collection, data requirements, functional requirements. Function requirements, we have a n number of things. Then we come with functional design with going for application development program using data requirements, conceptual design, logical design which talks about storage. So logical design which talks about tables, conceptual design talks about entire diagrammatic, then going for transaction with the application design program. So this is the beauty of what I call as data model for database design. When I go for thinking, see the subjects goes. So DBMS comes, OOC comes, then it comes with a software engineering. So this is the prerequisite. When you go for DBMS to learn, you want to know well with the software engineering, well with a little bit of OOC, because when I go talks about data types, it goes in a different way. So think about this. So think about this with the all the subjects makes wonderful called DBMS. So now next class I will start with writing a ER diagram with what are the features of ER diagram, what are the attributes, what is entity, what is attributes. So then I will go with the writing a constraints for a ER diagram, how the constraints can be built for a particular diagram. What is strong entity, what is weak entity, Using all this, how can you go for writing a ER diagram for particular applications? So everything I go with such a way. Everything goes with such a way. Okay. So next class I will discuss with start writing of a ER diagram. Okay. Hope you understand well. So it does a beautification. I go with a lot of examples. I tried my level best to you people to reach with the basic examples. Okay. Thank you. Thank you so much. We're hoping for next class with a fantastic ER diagram. Okay. Thank you.